pi over 6. Alright, now let's talk about arc length and central angles. Now, radian measure can be determined using a circle other than a unit circle. We were doing unit circles, but what about other circles? Either bigger or smaller than a unit circle. How do you determine radian measure with those? So, let's draw a unit circle first. Let's say this is our unit circle. There's one radius there, one unit of radius. And let's draw another circle of radius r, which let's say is not equal to 1. I'll make it bigger to make it easier to see on this paper, but it can be smaller than 1. The argument still applies. So let's say that's r radius right there. Alright, now we have arc lengths that go with our angle. Let's say here's our angle measure. We have arc lengths that go along with this angle. So let's call this one S1. Stands for the arc length on the unit circle. And let's call this arc length here S. Alright. And this angle here, we'll call that theta. Alright, now from geometry, the arcs that the angle marks out, or subtends as we say, the marks, or rather the arc lengths that the angle subtends, have their lengths in the same ratio as the radii of the circles. In other words, S over S1 is equal to R over 1. Alright, so this can also be written S1 over 1, if you do a little algebra, equals S over R. Now remember, S1 is the arc length on the unit circle, and we also said S1 is equal to theta. It's in radians, right? The angle here in radians is equal to the arc length on the unit circle. We mentioned that before. What we have here is S1 over 1, which is just S1, or, in other words, it's theta. So theta is equal to S over R. Alright? So, the radian measure theta of a rotation is the ratio of the distance S traveled by a point at radius r from the center of rotation to the length of radius r. In other words, if you want to know the radian measure of an angle using something other than a unit circle, you can use this formula. You take this arc length and divide it by the radius of that circle you're working with, and that'll give you your angle measure in radians. Now, when you use this formula, you have to make sure that theta is in radians and S and R are expressed in the same unit of measure. So, for example, find the measure of rotation in radians where a point 2 meters from the center of rotation travels 4 meters. In other words, let's say you have a point moving in a circle. We don't know where this point is. It could be a real problem, a real life problem, and so what we do is we draw XY axes going right through the center of the circle, and let's say according to the problem it says the point is 2 meters from the center of rotation. So here's your center of rotation, the origin, and it's 2 meters away, so the radius is going to be 2. Right? And the point travels 4 meters. In other words, the arc length is 4 meters. And this radius is 2 meters. So what is the measure of the rotation in radians? In other words, what's this angle that's formed? Angle theta. Alright, so we use the formula theta equals S over R. S here is 4 meters, and R is the radius, which is 2 meters. Meters cancels meters, so we end up with 4 over 2, which is 2. So theta equals 2, and again, there's no units here expressed, so this is in radians. Theta is 2 radians. Alright? Or in degrees, that would be, well, you can multiply that by 180 degrees over pi to get an exact answer. Or it's about 2 times 57 degrees, roughly, if you want a rough approximation. You would do that if you were, say, an engineer in the field and you wanted something rough to go by. You can go 2 times 57 degrees, right? Or 57.3 if you want to be a little more exact. Okay, here's another example. Find the length of an arc of a circle of radius 5 centimeters associated with an angle of pi over 3 radians. Okay, what does that mean? Well, let's see. We've got a circle. I'll draw my XY axes here at the center of the circle. And we want to find the length of an arc of a circle of radius 5 centimeters. So here's 5 centimeters in radius. And the angle here is pi over 3 radians. So what's the arc length? Question mark. Alright? Well, look at your formula. Theta here equals S over R, where S is the arc length and R is radius. I want S this time. Multiply both sides by R so you get S is equal to R theta. Alright? And what's R? It's 5 centimeters. So I write that in, 5 cm, times theta, which is pi over 3, and that's in radians, so I don't need any unit of measure. So I've got 5 pi over 3 centimeters. And that's the arc length measured out by that particle, or whatever it is we're talking about. 5 pi over 3 centimeters. Now, again, if you're an engineer, you would want to change that to a decimal, about 5.24. But I do want to see exact answers. Okay, let's talk about one more little topic here, and then we'll be finished. This is linear speed and angular speed. Linear speed and angular speed. Alright. Basically, what's the difference between the two? Angular speed is how fast something is rotating. Basically, you have something moving in a circle, and if you picture this, let's say you have a unit circle or something. Something is moving around this way, let's say, and you can draw an angle here representing the position of the point on this circle, and it will form an angle theta, like so, but the angle will be increasing as the point moves around the circle. So the angle is changing at a certain rate, or in other words, there's a speed associated with that angle. So in other words, you could tell how fast this point is moving around the circle, or you could measure, say, a rotating object with angular speed. All right? Linear speed is something you're most familiar with. If you're in a car and you're going down the road, basically, even though the road may be curved, you can consider it like a spaghetti and straighten it out. Consider it as a straight line, and you can measure the speed using the famous D equals RT formula. R equals D over T. That would be your average speed over the whole course. All right, that would be your linear speed. Okay, so if you look down at your speedometer, that tells you linear speeds. All right, so angular speed again, or rather linear speed, is distance traveled per unit of time. R equals distance divided by time. Okay, usually we write it like this. V equals S over T. We usually use S instead of D in higher mathematics and in science because D is often used for other things. So S represents distance, T is still time, and V stands for velocity, where, well, I'm not going to get into the difference between speed and velocity, but you will in calculus. Alright, so the velocity, or the linear speed, equals the distance divided by the time. Alright, now angular speed is the amount of rotation per unit of time. So, for example, you could talk about the angular speed of a bicycle wheel as 150 revolutions per minute. What's a revolution? Well, a revolution is referring to a rotation. One complete revolution would be 2 pi radians, or 360 degrees. So a point on this circle moves 360 degrees. Alright, the time that takes to do that would be angular speed. So 150 revolutions per minute on a bike wheel would be, pick a point on that bike wheel and time it for 1 minute. That point will travel, make complete circles 150 times every minute. Alright.